We're going to do some problems that will help you review for your first semester exam. First one is getting back to the random number table. So if you see here, we've got 20% of the cable subscribers that we want, using digits 0 through 9, which the following would be appropriate. So if we want to model cable subscribers, there are 10 digits, and we need 20% of them to be for the broadband subscribers. So it looks to me like 0 and 1 would be a good option there. The rest of the numbers would represent cable-only subscribers, so that would be 80%, and that is the correct answer. You can see with even digits, that would be 50% there. Here, that would be 30%, 60%. This is very tempting for students. That's actually 30% there, 0, 1, and 2. So once you get that right, you're going to assign the numbers and go. This kind of problem, if you've done regression, which we have, you have to know what this chart means. And so I look for these keywords like coefficients, kind of a key word here, and constant is a key word, and weight. Weight is actually your x variable. So your x variable is weight. That helps to know. So x would be weight here. One of those would be the right thing. This C and A are already out if you just know your x variable is there. The form of your equation is kind of like y hat equals a plus bx. Statisticians, we tend to put the constant first. So in this case, the constant is 21.84. So we would say 21.84 plus the coefficient is actually this guy. It's the number down below. So the constant is right to the right of the word constant. Coefficient is in the coefficient column, but it's 0.03. So 0.03 times x there. Or actually, we wouldn't say x. We would put in the word, which is weight. Same thing for y. Instead of saying y, we say the predicted y. In fact, we would say, what is it, moving times in minutes. So moving times. And so you can see this matches 21.84 plus this. B is the correct answer on this one as well. So here we have, this is the equation. You can see that this is the slope is this guy. The constant, or the y-intercept, is this one. So it says, correct interpretation for this slope. So we want to interpret 12.25. So right away you're thinking maybe one of these. That doesn't seem to be right, but let's actually see. Maybe let's read some of these. So for every increases of 100 units in x, the increase is approximately 1,225 units. When x equals 0, y is predicted to be 382. Well, that part is true. When x equals 0, y is certainly 382.1. That's true. For every increase in x, so this is 12.25 divided by 1, which is equivalent to 1,225. 1225 divided by 100. If you take the decimal point and move it, or multiply both top and bottom, numerator and denominator, by 100. So this is very tempting. A is a very tempting answer, but it's just one word that you have to read. You can see that this is a negative sign here. And so we know the slope is negative, which means it does not increase there. That would not be the right word. We think that y is decreasing approximately 1,225 units. For every 100 units increase in x, x is down below, slope is y, rise over run. Y is predicted, when x is 0, y is predicted to be 382, so this is definitely the right answer. A is very tempting there, but it's not the case. And it was kind of weird the way they said 12.25 is sort of over 1, but they just converted the fractions so that they were whole integer values. Here we have to kind of look at this and figure out what type. Is this binomial? Is this maybe a sample mean or sample proportion? So senior citizens make up about 12.4% of the American population. So my first thought is this is probably going to be a sample proportion problem, but we probably need to do some checks here. So let's do the conditions here. Is it random? It's the first condition for sample proportions. Hopefully it says something about being random. A random sample of 200 Americans. Check. Okay. Random sample. We could write that. Less than 10% of the population is represented in this sample. So is that true? Let's see. Sample of 200 Americans is selected. What is probably the 180 of them not suited? So 200 out of all the Americans, I guess, would be way less than 10%. So we're good on that. The other condition, so that we say check, is called success, fail. I realize that, for a multiple choice problem, you may not have to prove this is definitely sample proportion, but it's good to know this stuff. NP, because you'll have questions on this, must be greater than or equal to 10. That successes must be at least 10. So if we look at this and we go, okay, this is an interesting question. First of all, you've got to look at what is P here, because we're trying to figure out not senior citizens. We want to find out what is the probability that 100 are not senior citizens. So I think when you look at this 12.4%, that's not the percentage of not senior citizens. Senior citizens make up about 12.4%. So I'm going to take the complement of that. I'm going to say the probability of success is the complement of 12.4. So that would be 87.6%, or 1 minus 12.124, which would be 0.876. So that's probability of success is 0.876, which means Q, of course, is, what is that? Well, 12.4%. So if we plug in numbers here, we're going to get, let's see, we get N is 200. By the way, you should probably define that. N is 200. That's the sample size here. Times P is 0.876. And when you do that, you get about 175, which is certainly bigger than or equal to 10. And then if we do NQ, so NQ must be greater than or equal to 10. If we do that, we say 200 is N times Q is 0.124, and that's approximately 25, which is definitely bigger than or equal to 10. So it passes the success-fail condition. So it is sample proportions here. So we're really not looking at the binomial stuff here. That's more binomial. So I will use the formula for standard deviation for proportions, which is square root of PQ over N. And if you do that, let's see, for 20, so we get, this would be square root of 0.876 times 0.124 divided by 200. And if you do that in your calculator, but we really don't have to do that, do we? You can see that that is really over here and here. So this is actually using the wrong formula. That's the formula for means. So this would be a means problem. So it's not that if it was standard deviation over square root of N. So it's going to be one of these. And so the formula basically for z-score is your sample proportion, like p hat, minus p over your standard deviation. And so p hat would be 0.9 because 180 out of 200 is 90%. So we want 90%, so it's going to be 0.9. And again, our p-value is 0.876, so E looks to be the right answer. This is a hard question, especially because of the way the answer is written. My students are going to, it's almost easier to calculate it using norm CDF than it is to pick out this as the answer. But we're basically saying that whatever the z-value is, that when we graph that, it's going to be greater than that. The graph is going to look kind of like that, and we'll figure out that probability using like a norm CDF kind of thing. Let's look at 23. So the average score was 38. Students scored 40 last year. Students scored 35. The average score this year was 38 with standard deviation 2. Last year's average was 34 with standard deviation of 1. And which year was the student score better? So this is like comparing, like we did, comparing ACT and SCT scores. So if we look at it as z-scores, we can definitely do this. So let's do last year's first here. So if we do last year's, I think the average was, what, 34, and the standard deviation was 1. So one standard deviation would be 35, and the other direction would be 33, and 2 would be 36, and 32, and so forth. And it says that the score this year was, last year, 40 last year's, excuse me, 35. So the student scored 35 in last year's competition, which I can calculate that right away. The z-score there is 1. It's 1 standard deviation away here. And if we do this year's scores, 38 was in the middle. That's the average, and I think it was 2 for the standard deviation. So this would be 40, 42, 36, 34, and so forth. And I think his score last year was 40, which again, I can do that standard deviation. I don't have to use any kind of inverse norm or anything, or any kind of commands to figure that out. I would just say z equals 1. Z equals 1, and for both of these, they're exactly 1 standard deviation to the right, so they scored equally well. There's really no way to tell that he scored better in one than the other. It's kind of an interesting question here. So if you take time to look at this, the mean is 12.62. So if I look at some of these, 12.6, well, 12.6, both of those are out because you can see mean is not there. The mean would be the balancing point. 12.6, okay, maybe. 12.6, maybe. 12.6, maybe. Any of those might be the mean there. Standard deviation of the population here, which was skewed right, is 9.6. But we know from our formulas, if this is sample means, the standard deviation for sample means is the standard deviation of the population divided by square root of n. So in this case, this would be 9.6 divided by square root of size 9 would be the n value there. So n, I can almost do that in my head, 9.6 divided by 3 is, I think, 3.2 or something like that, 3.1 or 2. So we've got standard deviation is about 3. So if I kind of go 3 units to the right, I would expect this is starting to look normal, or it should start to look normal with the size of 9. If it was 30, I would definitely say it would look pretty normal. So it could be really any of these. I'm leaning towards not this one. It looks a little too much like the population. I'm thinking it might be one of these. But 3 standard deviations each direction would be 9 units. So if this is 12 or 13, add 9, that'd be about 22 to right there. That's 3 standard deviations. Subtract 9 from 12, that would be about 3. All the data should be about within there. Well, that doesn't look right there. If I go 9 to the right, well, that's way out there, isn't it? 9 to the left is way out there. This doesn't look right. Let's go about 9 to the right. 13 or 12 plus 9 is 21. That's about right. 12 or so, 12 or 13 minus 9 is about 3 or so. Well, it's not quite there, but this seems like the best choice, and I would probably choose E. It's kind of a guesstimate anyway. We're not quite sure on that one. This one's pretty challenging. I think I'm going to wait till my next screencast, part C, to tackle this one. Cumulative frequencies are always challenging, so we'll start with this one.